2026. From our side, the people who were responsible for this paper, we did not receive many complaints, albeit for one complaint on question 1.5, and then we'll discuss it. But I must say, colleagues, if you have anything that you came across as you were going through the paper, please share it with your subject advisors, and then they will forward it to us so that we can incorporate in the final memo, in the final marking guideline. Having said all that, I would like to start with our marking guideline discussion for grade 11 physical sciences 2026. For multiple choice questions, colleagues, like I said, the only complaint or something, in fact, it's not even a complaint. It is something that we realized as we were preparing for this discussion. When it comes to question 1.5, and then we decided that we will then remove the question and distribute the 2 marks as we move with our paper. You see, with this question, colleagues, maybe it is something that we need to discuss, or where the problem is with this question. The trolley shown below is pushed at constant velocity outside the mall and experiences the frictional force F between the wheels and the pavement. The trolley then enters the mall with a smoother tile surface. Up to here, one will expect that the velocity must change and it must increase. But the statement after that says the speed of the trolley remains the same throughout the motion. Then that took out everything, and then it took the question and the science out of context. Hence, we said there is no correct option available for learners here, because once we say the speed of the trolleys remains the same throughout, then it means the net force must be 0, but we do not have the option where the net force is equal to 0. Hence, after consideration, we then decided maybe let us remove this 1.5. But it is something that we realized as we were preparing for this discussion. And we did not receive anything from you, colleagues, or any other person. I do not know if Lerona, in that consideration, we might have missed something. If there is anything, colleagues, that you think or no, maybe this question is still correct and it is answerable, learners will be able to deal with it. Maybe you can share with us. But from where we are standing at the moment, we think there is no correct option for this. The intention, yes, was for the net force to increase so that option D becomes correct. But I think we lost it when we included this statement there. The speed of the trolley remains the same throughout the motion. So that for us took this question out of context, and then made the science to be incorrect. Not the science necessarily to be incorrect, but there won't be any option that will be correct for this question with that statement in. I will open this for any comments from colleagues. Otherwise, 1.5 will be removed and the 2 marks will be distributed as we move along. And then another issue, not necessarily an issue, but then 1.4, some people think, I don't know, or rather thought, or maybe this was a difficult question. It was not necessarily a difficult question, colleagues. If you go through the question, we have a man that is exercising there by moving weight stacks from position S to position U, as shown in the diagram below. Then the weight stack is lifted, or the weight stack being lifted has a weight W. That is what we are told. Then learners were asked to find the tension at position U in terms of the tension at position S. So the way we will deal with that, we'll say if we were to draw the free body diagram at position S, this is how the free body diagram for the weight stack at position S will look like. Remember, at position S, the weight stack is still on the surface. It has not yet been lifted. But at position U, you will not have the normal force because now the weight stack is in the air. It has been lifted up. So if we are to draw a free body diagram, then we'll end up with weight at position S being equal to S, that is tension at position S plus the normal. And then at position U, that is where we'll have weight being equals to tension at that position. Then weight remains the same. Weight of the stack is the same. Therefore, if we were to equate the two equations, then we'll end up with TU being equals to TS plus the normal. So which then makes option number D correct. So this will come with the final memo, colleagues. Otherwise, besides question 1.4 and 1.5 being removed, yeah, I do not think there are any other problems with reference to question number 1, unless colleagues have questions. So before we move to question 2, let me open up this for any clarity seeking questions on any of the questions on question 1. Colleagues will help me with the hands if I can't see them or anything in the chat.
Good morning, colleagues. So far, that I'm happy there's nothing.
Okay.
We'll wait for colleagues to check.
Yes, I don't remember the comment on question 1.5. Am I making sense? I just want to check with colleagues, especially for 1.5. Is it correct?
That I'm happy for 1.5, there's nothing. And then for 1.4, let us discuss it after the meeting.
Oh, okay. All right. No, thank you very much. And then let us then move on with the marking guideline for question number. Are you still on, Memancho?
Yes, since there's nothing on the chat and nothing, no hands, let us continue to question 2 on that.
Okay. Then with question 2, that was on vectors in 2 dimension. Colleagues, please remember to fill in all the documentation if you are at the marking center in your respective circuits. And please, after the session, send the documentation to your subject advisors. Immediately after the session, please send the documentation to your subject advisors, colleagues, please. And then there will be, with the invited to this marking guideline, there will be an attendance register. Please fill in the attendance register. So you must fill in the attendance register at the center and also the online attendance register. So question number 2. A box of mass 10 kilograms is held stationary from a roof as shown below. There are 2 strings attached to the box. You have the diagram there. Then 2.1 learners were asked to explain what is meant by resultant force. And as you can see, colleagues, that the force is bolded there. The intention was for learners to be specific in their explanation. So we'll then accept if a learner writes an explanation with reference to the force. So we are not going to accept a general definition of a resultant, colleagues. So the acceptable answer for this one, a single force with the same effect as 2 or more forces together. That is what we will accept, colleagues. If a learner just writes a single vector with the same effect as 2 or more vectors together, colleagues, you are not going to accept. So learners were supposed to be specific to the force in this case as a vector. So if a learner gives the general definition of a resultant vector, we are not going to give. We will only give if a learner is specific to the force. And that will be 2 or 0 there. And then we will also accept if a learner writes a vector sum of 2 or more forces. 2 or more forces. We will also accept this one. Then 1.2, or rather 2.2, then learners were asked what is the resultant force acting on the box? The resultant force acting on the box, the answer there is 0, 1 mark. And then 2.3, learners were asked if weight is a vector or a scalar quantity, and then they should give a reason for that. Then the answer there will be a vector. Reason being it has magnitude and direction. So it will be 1 mark for vector. It has magnitude and direction, another mark. So for 2.3, the marks will be 2 marks. And then 2.4, learners were asked to draw a head-to-tail diagram of all forces acting on the box, So because the net force is equal to 0 there, we expect a closed vector diagram. In terms of the directions, this is more or less the diagram that we are expecting. So we'll have T1 moving in that direction, T2 moving in that direction there, T or weight moving in that direction. So if you have all, or rather a learner has all 3 forces as shown in the diagram and labeled, that will be 1 mark if you look at the marking criteria. You look for T1, T2, and weight. If they are there and they are shown in the diagram, then that will be 1 mark. If the direction of the forces is correct, all of them, the direction must be correct. So it is direction of T1, direction of T1, direction of T2, and direction of weight. If all those directions are correct, then that will be the 2nd mark. And if the diagram makes a closed, or rather it is a closed diagram like it is the case here, then that will be where the 3rd mark will be. That is the 3 marks. So 1 mark, all forces shown in the diagram, and they are labeled. They must not only be shown, they must be correctly labeled with T1, T2, and W. If you have them there, then you can give 1 mark. And then if the direction of the forces is correct, they do not need to show directions. But if you can see that the T1 is moving in that direction, and this one, T1 is moving in that direction, and T2 is moving in that direction, and weight is moving straight downwards, we'll then give the 2nd mark. If all these forces then make a closed diagram, that is where our 3rd mark will be. I believe that that is clear, colleagues. If it is not, after the discussion of question 2, please feel free to ask questions. Then when we move to question 2.5, learners were then asked to calculate the tension T2 and the angle theta with respect to the positive x-axis. Colleagues will see after the discussion here or now, this will be 8 marks. The 2 marks that, one of the marks from the 2 marks that we took from 1.5 will be given to 2.5. So let us go to the marking guideline for 2.5. To do the calculation, learners were expected to do the components. They will first have to calculate the component of the horizontal or the x components of T1. So in the substitution of the calculation of the component, horizontal component of T1, that is where the 1st mark will be. That is where we'll have the 1st mark, but because this is, or rather, T1x and T2x will be the only forces acting horizontally on the block, we'll then say this force will then be equal to T2x. Okay, colleagues. Then learners will then have to calculate the y component of T1. because for T1, at least we have the magnitude and the angle. So the calculation of the y component of T1 this year will be 1 Mach. And then the calculation of weight in the substitution of weight, not on the formula, colleagues. Here on the substitution of the weight, that is where another Mach will be. And then to find T2y, the vertical component of T2, a learner will then have to say 98 newtons, subtract the y components of T1 to get the 73 newtons. So this subtraction here will then give us 1 Mach, because vertically it is stationary, and then the forces that are acting vertically on that block, you will have your y component of T1, y component of T2, and then the weight. Y component of T1 and y component of T2, they will be going up, and then weight will be going down on that. Then therefore T2y will be given by 98 minus 25. Then for the subtraction there, you'll get Elena will get 1 Mach. That is 1, 2, 3, 4 Machs up to this point. Then the learner will then have to calculate an angle theta. Now that the learner will then have the vertical and the horizontal component of T2 using the tangent ratio, a learner can find the angle being 59,33, but the Mach is not on the angle there. The Mach is on the substitution into the tangent ratio there. So tangent inverse of 73 over 43,301. This whole thing will be 1 Mach. When it comes to the magnitude of T2, a learner can use trig ratios or Pythagoras theorem, whichever one a learner chooses. So if the learner uses the sine ratio into the substitution thereof, after finding the angle, the substitution will be 1 Mach into the sine ratio. And then the substitution into the cosine ratio, if the learner chooses the horizontal component of T2, after finding the angle, the substitution into that will be 1 Mach. But I think the first option for the learner should be to use Pythagoras theorem, now that they will have the y and the x component of T2. So with Pythagoras theorem, they must be able to find the magnitude of T2. But the Mach is not on the magnitude yet. The Mach will be into the substitution here. The substitution of the horizontal and the vertical components that they will have found using the components up there. So 1 Mach will be there. And then the Machs that we have now is 1, 2, 3, 4, 5, 6. And now the learner will then have to conclude and give us the magnitude. T2 is equals to this for the magnitude, 1 Mach. And now the angle with respect to the positive x-axis. So the angle 59,33 degrees anti-clockwise from positive x-axis. This whole thing here will then be the 8th Mach on question 2. It is 2.5, if I'm not mistaken. Yes, it is 2.5, colleagues. So that is the Mach allocation for 2.5. And as I indicated in the memo that we distributed yesterday, the total Mach here was 7, but now the Machs must be 8. 1 Mach for calculation of x components of T1, 1 Mach for calculation of y components of T1, 1 Mach for calculation on the weight, 1 Mach on finding T2y, that is 98 minus 25 newtons. 1 Mach for substitution into the formula to find, or ratio to find the angle. And then 1 Mach into the substitution to find the magnitude of the force, which is T2. And the learner can either use the trig ratios, your sine and the cos, or I think most of them will go for the Pythagoras theorem. Substitution into that Pythagoras theorem, that will be 1 mark. And then we'll have a mark on the magnitude of T2, and then a mark on 59.33 degrees anticlockwise from positive x-axis. Because if I'm not mistaken, on the question, learners were asked to find the angle with respect to the positive x-axis. So they then need to specify how they measure it with respect to the positive x-axis. Then the total for question number 2 will be 16 marks, and the allocation is as I have explained it, colleagues. Now I'll open for any clarity seeking questions. Thank you very much.
Okay, thank you, Dr. MOHAPI. Before we go to the questions, can you move to the last 2.4, the last, that Pythagoras part?
Okay.
Remember, T2 squared was that 43, comma, squared plus 73. Therefore, you have to conclude that T2 is 84.88. It's not T2 squared that is 88.88 again.
Come again, ma'am?
The last part, the last row.
Oh, here.
It's T2.
It's yes. T2, yes. Okay, ma'am.
Okay, the first question is from Mojali Mokoena. Mr. Mokoena, you can just unmute and go on. Mojali Mokoena, please unmute and carry on. We can't hear you.
Yeah.
Whilst Mojali, okay, all right.
No, I was saying maybe we should take another person because it seems like
Mojali is trying to unmute or something. Let's go to Alicia. Alicia, please continue.
Good morning, colleagues. My question is on question 2.4, that very last marking allocation for the anti-clockwise from the x-axis. I think the question stated to calculate the angle in respect to the positive x-axis, and by the looks of it on the sketch, it is above the x-axis or anti-clockwise. I just feel it is a bit unfair towards the children who calculated the angle and did not put in anti-clockwise. Can we maybe revise that as it is only the 59? Obviously, when they calculated it as 30, I think the other angle is 30 point something. Can we just allocate the mark on 59.33?
Okay. Yeah, no, I hear you. I hear you because from the diagram it's already directing them. Yeah, but then if they get that one, the 39 something, 90 minus 59.33, then we'll not accept. No problem, ma'am. We can give for 59.33. It's okay. Okay.
Thank
so
you.
colleagues,
Okay.
we can give even if the learners did not say anti-clockwise from positive x-axis because it is given there in the diagram. They can see, yeah. No, thank you, ma'am.
Okay, colleagues, I think that is clear. Are you ready? Mr. Mujal Famkwena, if you can't maybe unmute or you're not audible, please type it on the chat, then we can address it on the chat. Okay, Mr. MOHAPI, there's one question on the chat from Yegedzi Shahani. In question 2.1, can't we regard a force as a vector linear? Maybe Ndate was not connected yet. Can you clarify that one, Mr. MOHAPI? The
Yeah,
question is, in 2.1, can't we regard a force as a vector, Menier?
yeah. No, here we were expecting learners to be specific. Hence, you see the force bolded there in here. Ne? So we wanted learners to be specific to the definition of resultant force. So we are not going to accept if a learner gives the general definition that is yes, a force is a vector, but that definition using a vector is a general definition. So here we were looking for a learner to be specific. And I think this is a good training for them because they will be required in some cases to be specific to the situation that is given to them. So we are not going to accept the general definition, Minier, and it is 2 or 0. Hence the bold. Hence the bold there. Thank you very much, Min.
Okay, Mojalo Famukwena has typed on the chat. It says, he says 2 or 0 is too harsh. Can we please reduce to 1 mark?
Yeah. We will come
What
back
do you
to
think about it?
Yeah, we'll come back to them. But from where I'm standing, I don't agree. But then we'll come back.
Okay.
Mhm.
Whilst we on it, Mr. Taizani, over to you, Ndad. Mojalo Famukwena, please lower your hand because we have already addressed your question on the chat. Please lower your hand. Over to you, Mr. Taizani.
Good morning, colleagues.
Morning, Daddy.
I was just requesting, I'm not sure whether it is on our side, if in that MOHAPI can zoom a little bit. We are unable to see the details on the screen. Thank you.
All right, Minier. No, we'll do that.
Okay, that will be addressed. Most I'm happy there's teaser. Teaser, can you unmute and say what your question is?
Morning, colleagues.
Morning, Minier.
On the last question, 2.4.
It is now 2.5, ne? This one.
Oh, sorry. Oh, yes, that one.
Okay.
I'm seeing one option for the answer where the learners must use the components. What if the learner used the closed vector diagram from the previous question?
Okay. I just want to check, calculate, and then they use the closed vector diagram.
Yes. Because
Okay.
the only unknowns will be T2 and theta.
And then they use the scale drawing.
No, normal calculations, trig ratios.
Okay. So can you send that option to us so that we can have a look at it?
Yes.
Minia? Yes, please send it to your subject advisor so that they can then refer it to us. And then, yeah, we'll have a look. And then if we accept, then we will include it in the final memo.
Okay, sir.
Okay, Minia.
Thank you.
Thank you.
Okay, let them happy. That's all that we have. I don't know. I think in that day, Mojalo Famukwena, I will get back to him after
The issue
everything is
of,
done.
yeah, maybe we
Because he
should.
says 2 or 0 is too harsh. Can we please reduce to 1 mark? It's not part of the framework.
What is not part of the framework?
I don't know.
Okay. Yeah. Maybe we'll explain. I don't think he says definition or rather explaining resultant force is not part of the framework. I doubt he's saying that. But hey, we'll get back to him. But from where we are standing at the moment, we don't feel like giving him.
Okay.
Okay.
There's no other hand that I'm happy.
Okay. Then we'll move on to question number 3, colleagues. Question number 3 was more of an experiment type of a question where learners performed an experiment to investigate the relationship between net force and acceleration. They set up the apparatus as shown below. Each mass piece has a mass of 0.1 kilograms and the cart has a mass of 0.5 kilograms. And then it is observed that the cart did not move. The teacher then advises learners to start the investigation over, but with the tilted track as shown below. I think this is the experiment that the learners are supposed to do at schools. Then the cart started to move. Then 3.1, what was the reason for tilting the track? What was the reason for tilting the track? Then the answer that we were expecting there, to compensate for friction or to overcome friction. That will be 1 mark. And then the next question, for this experiment, identify the controlled variable. Then the controlled variable will be the mass. And then for this experiment, identify the independent variable. Then the independent variable thing that is being changed there, it is the net force. The net force is the one that has been changed. And then question number 3, calculate the mass of the system for 2 marks. Learners, we expected to calculate the mass of the system for 2 marks. Mass of the system, it will be the mass of the mass pieces plus the mass of the cart. Then it will be, we have 8 mass pieces of 0.1 kilograms plus 0.5 kilograms, and the total there will be 1.3 kilograms as the total. So the mark will be on the substitution there and the final answer. But we can accept if a learner just writes 1.3 kilograms, just give 2 marks if a learner just writes 1.3 kilograms. Then the last question here, colleagues, it is using symbols. Write down the conclusion for this investigation. Like here again, we are specific in saying using symbols, colleagues. I hope you are not going to ask that we then give 1 mark if a learner then uses words. Here we want symbols. So in terms of the symbols, the learner will write F net directly proportional to acceleration with symbols. If a learner gives weights, the conclusion using weights as case, but it is 0. That is question number 3. I do not know if there are any questions, colleagues.
Yes, thank you, Dr. Mohapi. We have a question from Alicia. Please unmute.
Yes, I just have a question on question 3.2.1, the controlled variable. Can we also accept that the inclination of the trolley track is kept constant? As it was tilted, it should have been kept constant, otherwise it will influence friction.
Okay, and then the variable there will say the inclination.
The inclination of, or the angle of inclination on the track.
Because I want to find the variable, the exact variable that we are changing when we affect or rather change the inclination. But I get, yes. I hear what you are saying, ma'am. Yeah, we will consider it. I think it makes sense, yes, ma'am.
All right, and then also, I think more appropriate answer shouldn't be mass, but the mass of the trolley. Otherwise, they can refer to the mass pieces, or we can accept the mass pieces that should be kept constant. But I think more specifically, it was the mass of the trolley that should be kept constant, not only mass.
Okay, and the trolley will mean the mass pieces and the cart combined.
Yes.
All right, okay, okay. No, it's fine. It's okay, man. Okay.
All right. Thank you.
Thank you very much. Okay.
Okay, thank you. On the chart, Mr. MOHAPI, 3.1, to allow the trolley to move at constant velocity. Do we accept?
So do what?
3.1 was, what was the reason for tilting the track? So the answer the learner gives is to allow the trolley to move at constant velocity. So the question is, can we accept that answer?
No. No, ma'am, we can't. Because the tilting has to do with compensating the friction or changing the friction there. Yes. No, we can't accept that one.
Okay.
And
Another
then
question.
yeah, I wonder how is it going to move at constant velocity because it is accelerating. Then the trolley will accelerate. So we'll not have it moving at constant velocity. Okay.
Okay, that I'm happy. Another question on the chart. In 3.4, if net is omitted, can we accept?
No, because it is even stated in the statement then between the net force and acceleration. So the conclusion must give the relationship between the independent and the dependent variable. So the independent variable here is the net force, not the force, but the net force. So we will not accept, because now we have friction together with what? Yeah, we can say friction together with the force acting on the object. So we can't accept that, man.
Is that 0?
It's 0, yes, because now it is 2 or 0 there.
Okay, that I'm happy. There's a question from Mieketsi Shahane. A hand just came up. Mieketsi, please unmute. The hand is now lowered, so I guess you are covered. Mieketsi? There's no question. The hand is lowered. That I'm happy. Oh, it's up
The hand
again.
is up again.
Mieketsi, please unmute and talk. Mieketsi Shahane, please unmute and talk.
Yeah, it seems like Mwegezi has a problem with the mic also. Maybe you were
Mieketsi,
right.
please type on chat.
Yeah.
Please type on chat. Because we are almost done with question 3, we will get back to it if you type it. Thank you, Ndate Happy. There seems to be no hands and nothing on chat, so you can move to question 4 then.
Question 4, the velocity time graph below shows a motion of a car traveling westward on a horizontal surface. The mass of the car is 1,200 kilograms and the coefficient of kinetic friction is 0.16. We have a velocity versus time graph there for the car, colleagues. And the first question, 4.1, the learners were asked to define the kinetic frictional force. Kinetic frictional force, the definition as taken from the examination guideline. We resolved yesterday that we are only going to accept the definitions from examination guideline. So the definition there, it says the force that opposes the motion of a moving object relative to the surface or to a surface. So 4.1, 2 or 0. The force that opposes the motion of an object moving relative to a surface. Then the next question, is the net force 0 between 2 and 4 seconds? between 2 and 4 seconds, net force cannot be 0 because we can see from that point the object is accelerating in the negative direction, or rather it is decelerating as the velocity is decreasing. So the answer there, from 2 to 4 seconds, the answer should be no. And then 2 marks for no. Then 4.3. During the interval where the brakes are applied, then the learners must realize where the brakes are applied. It will obviously be where the velocity is decreasing, and that will be between 2 and 4 seconds. So during the interval where the car brakes are applied, then we have to answer questions based on that time interval. Or rather, they were expected to answer questions based on that time interval. And that time interval will be between 2 seconds and 4 seconds. So if we go to the question 4.3.1, learners were asked to draw a labeled free body diagram. Remember, the car was moving westward. The car was moving westward. Then the free body diagram will be net normal force, gravitational force, frictional force, and the applied force, or the force of the brakes opposing the motion of the object. So you'll have normal force acting on an object, gravitational force, frictional force, and force of the brakes or the applied force. Because initially the car was moving westward, we then expect the frictional force and the force of the brakes to go east or to the right. So the correct direction of the force of the brake and the friction, colleagues, please be careful when it comes to those things. Then the acceptable labels for normal force will accept Fn, F normal. For applied force, we'll accept F capital letter A for F brake, or F brake, yes, or F applied as a whole, or applied force. For friction, we'll accept kinetic friction, we'll accept friction, F friction, Fk. For gravitational force, we'll accept F gravitation, weight in weights, mg. Those are the acceptable labels for the forces that are acting on an object as the brakes are being applied. So here are the notes. Mark is awarded for a label and the arrow. Do not penalize for the lengths of the vectors. If arrows do not touch the dot, which is the object, we deduct 1 mark. Then the learner will get 3 out of 4. We only penalize once for that mistake. If any additional force, or rather if we have any additional force, we deduct 1 mark. For 1 additional force, we deduct 1 mark, but we only penalize once. No arrows with correct labels, we then deduct 1 mark also there. Those are the notes when it comes to 4.3.1. And then 4.3.2, calculate the net force acting between, or rather within that interval, 2 to 4 seconds, because that is where the brakes are being applied. Hence, the velocity decreases. When we do that, we'll have F net being equal to MA. We have the mass of an object, which is equal to 1,200. The acceleration will be change in velocity over change in time. And then change in velocity there, we are in final velocity of ours, it is 10. And initial velocity, it is, our final velocity is 6, sorry. initial velocity, it is 10 because it is decreasing, over 4 minus 2. Then the answer will be negative 2,400 newtons, which will be 2,400 newtons eastward or to the right. So the mark allocation will be 1 mark for the correct formula, 1 mark for the substitution into the calculation of acceleration alone, colleagues. So 6 minus 10 over 2 or over 4 minus 2, that substitution alone will have a mark. And the third mark will be for total substitution into the formula F net is equals to MA, where now the acceleration that has been calculated is then multiplied by the mass. That total substitution into that formula will then have a mark. So we'll not have a mark on negative 2,400 newtons, but the learner must show it. The learner must show negative 2,400 newtons because according to this calculation, the first answer that the learner will get is negative 2,400 newtons before they get to this one where they now interpret and say 2,400 newtons, and then they say eastward or to the right. So that is the mark allocation on question 4.3.2. Yeah, I think it was 5 marks. Yes, that is how the 5 marks will be allocated. Then question number 4.4. Then learners are asked to calculate the force applied by the engine now during 4 to 6 seconds. Now the car starts to move at constant velocity of 6. But for us to be able to do that, it means the force must be applied as you drive a car. You must apply a force there. Then to calculate the force applied, we'll say F net is equals to MA, the kinetic frictional force will be acting on the object and obviously the force from the engine. But because for that period, the object is moving at constant velocity of 6, then the acceleration will be 0. So we'll have F net being equal to 0, hence the 0 on this side. Then we'll have that force minus the kinetic frictional force acting on an object. The kinetic frictional force will be 0.16 multiplied by 1,200 multiplied by 9.8. And then when you do your calculation there, then the force applied must be 1,881.60 newtons. In which direction? Westward direction. So the mark allocation for 4.4 will not have a mark on the formula, colleagues. For 4.4 will not have a mark on the formula. The mark will be on the substitution of 0 on this other side, because the object is now moving at constant velocity. And the other mark will be substitution on the left-hand side, where you will have F minus 0.16 multiplied by 1,200 multiplied by 9.8, because that is the calculation of the frictional force or kinetic frictional force. So 1 mark on the left-hand side, the whole of the left-hand side, and then 1 mark on the right-hand side for 0. It must be 0 there, or rather 0 must be shown somehow. And then F is equals to 1,881.60 newtons, 1 mark for the magnitude, and that will be westward or to the left, 1 mark for direction. So that will be the allocation of the marks for 4.4, and that is that for question number 4, colleagues. Memancho, I'll give for colleagues
Thank you,
to
Madam
ask
Happy.
the questions.
Okay. We have 2 questions so far that I'm happy. The first is Me Elisha Fisache. Me Fisache, please unmute.
Good day again. Question 4.3.1 on the free body diagram. Should a learner have drawn everything correct, but the direction of the force applied and the frictional force is towards the left, I assume they lose the 2 marks, and then everything onwards would be also incorrect regarding direction.
Unfortunately, there will be. Yes, ma'am, it will be incorrect moving forward. Yes. I
Alright.
think you are asking if we are going to mark positively from free body diagram.
Yeah, but I
Yeah.
assume that it's going to be incorrect. I just wanted
Yeah.
to confirm. All right,
No,
thank
it
you.
will be incorrect, ma'am. Yes. Okay. Yeah. I see Sahani.
Okay, Ndadem Happy, before we move on, Ndadenzi would like to come in there on that.
Oh,
Colleagues, for that one, that I'm happy, can really consider that we are actually marking the skill, isn't it? That the learner in 432, we are checking with the learners if they can apply what they see. So the learner has identified the forces. So to say we are not gonna mark further, everything is wrong, I think we're becoming too harsh. Let us look at what is it that we are marking, or the question was all about. We wanted to check if the learner is able to can apply the principle as it is. So let us check. Really, I think there we need to reconsider. I think it is too harsh.
where
Anyway,
Minier,
that's my
where a learner now changes direction of the friction and direction of the brakes.
No, I get it. If we are looking at 4.4, the principle is to apply Newton's second law,
Yes.
isn't it? Now, from the free body diagram, that
Mm.
learner has a wrong direction for friction, the way it was told.
Mm-hmm.
Now, if that learner is telling you that, according to me, my F net, then it is how I see it from the previous on the free body diagram, I don't see the reason why should we make it wrong. Because it's a skill that this learner is showing us that there is a Newton's second law which is applicable.
Yeah, but I want to check where does the direction of free, okay, here for friction, instead of it being negative, Baba, it's a positive.
We make it
Is that what you are saying?
positive, yes. That is
He
what I'm
say it is
saying.
positive.
According to his free body diagram, that is what the previous speaker was saying. And we want that skill that the learner is able to can apply, because the mark we see it is on that substitution, the whole of that there is a force in that particular direction, and there is friction also in that particular direction. That mark is for whole of that substitution, or is it on the friction only?
Yeah, but I'm worried about now the science in that, Minir. You should understand what I'm saying. So if the learner substitute friction here as positive together with the applied force now being in the same direction, does that learner mean the applied force and the friction for that period of 6 to onwards, from 4 to 6, I think, does that learner say or the two are moving in the same direction? Can we agree to that?
Let's check from what we are saying. For this friction to be negative, it's still coming from the free body diagram, isn't it?
Yeah, even though the situation has now
Yeah.
changed. You see why I'm saying the situation has changed, meaning? The situation, we are now no longer giving breaks. Remember.
That is what I'm saying. Are we marking the skill, or are we marking the situation?
The situation has changed. Okay. No, yeah, we can discuss
That's
it,
fine.
colleagues, and then agree. Because for me, the situation has now changed from what we had in the free body diagram. That's for me. But we can discuss
I
it.
am
It's okay.
in agreement with you. The only problem that I'm having is, remember, what is it that we are marking? We are marking the skill that the learner is showing. So from his free body diagram, we have penalized already. Now we are penalizing this learner for the same mistake that he's doing about the friction. You see, that's the thing, but let's leave it. Let's leave it as it is, if maybe colleagues are comfortable with it.
Yeah, no, it is me
Okay.
who's not comfortable with, with giving it, but then we can discuss it. For me, the situation has changed. The free body diagram for me is not related to 4.4. 4.4 is totally
Okay,
different
Dr.
from
Mohapi.
the free body diagram. But then, yeah, we can discuss it
It can
somewhere.
further be discussed then. And
Yeah.
then we'll get back to the colleagues.
With the final memo, yes, ma'am.
Yes. And then there's another question from Mieketsi. Mr. Shahani.
Am I audible?
Yeah, you are finally, Minier.
Oh, thank you very much. No, Mr. Dlamini. On 4.3.2, if the learner had 4.3.2,
Yes, Minier.
yeah, the learner decided there to say FNet is equals to MA, then they substituted 1,200 times -2. Yeah, they just wrote -2 there without even calculating it from anywhere. So what do I do? Do I give them a mark?
They did not show where they got that -2.
Yes, it did not show.
Ahmad, it's correct, man. You can give me this one.
Okay, thank you very much.
Yeah, okay. It's correct. So we'll take it or wherever the learner did it. As you can see, the answer is correct. Then we will give, yeah. Okay. Memanchu?
Thank you, Dr. Mohapi. Dr. Dlamini, please lower your hand if you're done, unless there's more. Okay, thank you. And Dr. Mohapi, let's go back. There's that question on the chart that takes you back to question 3.1.
Okay.
It says, should we accept to change or decrease normal force since it directly changes the frictional force? So the question says, should we accept if the learner says to change or decrease the normal force? Because saying that is directly changes the frictional force. That's the question.
Hey. Yeah, I get the idea, but what directly influences the net force is not normal force. Normal force influences it indirectly. The direct force that influences the net force, it is the friction. So the learner has to specify friction. I think, colleagues, some of the things that we will want to accept for the learners will then mislead them when they answer questions in future. Then the learner must check what is it that is changing. Then whatever that we talk to must be something that will directly influence the independent variable that we are changing here. Normal force, yes, it influences it, but indirectly. I don't know, Memanchu, if you get what I'm saying. Because now a learner will write that, we accept it now, and then the learner goes on to write it in future, then we do not make it correct somewhere. So I'm saying as we teach colleagues, maybe we need to tell our learners so they need to be specific to something that influences the variable. So go directly. So normal force does not influence the net force directly. It has first to influence the frictional force, then the frictional force is the one that will then influence the net force.
I think that is loud and clear. And especially since now we are still at the beginning of the year, it is important to mark as strict as possible so that we remove any possible misconceptions right now. Because remember, this topic also moves to grade 12. So it is important that we remove those misconceptions. And colleagues, let us ensure that we explain to our learners why we don't accept that. Thank you, Dr. Mohapi. No more questions, no hands. So I think you can move to question 5.
All right. Question 5 was on universal gravitation, Newton's law of universal gravitation. There, colleagues, The diagram below shows the satellite that is orbiting above the surface of the Earth. The satellite has a mass of 419,725 kilograms and experiences the gravitational force of 3.64 times 10 to the power 6 newtons due to Earth. Then the first question, learners were expected to define weight. Colleagues will forgive us. Most of the definitions, in fact, all of them are 2 or 0. So even here, as given in the examination guideline, the gravitational force in newtons exerted by Earth on the object. The gravitational force in newtons exerted by Earth on the object, on an object. So that is that, colleagues. Maybe if a learner just writes a force exerted by Earth on an object, yeah, we can accept that because they will know that weight and gravitational force is the same thing. So if a learner just starts by saying the force exerted by Earth on an object, then we can accept. But for this, like the previous ones that we have dealt with so far, 2 or 0. Then the next question, a man has a weight of 650 newtons on Earth. Then learners were asked to calculate his mass on the International Space Station, ISS. So here we were checking with the learners as to whether they will understand or the mass of an object or of a person will not change if a person moves from one maybe planet to the other planet or one place to the other place. The mass will remain the same. The only thing that will change is the weight of that person because of gravitational acceleration, but the mass will remain the same. So the learner can use information on Earth to calculate the mass of the person. So the answer here will be FG elekanale mg, then that is weight 650 newtons, m 9.8, then the mass of that person will be 63.33 kilograms. So that is the 3 marks, colleagues, there. Then the next question, 5.3, calculate how many kilometers above the Earth's surface is the satellite moving if it experiences the same gravitational force to keep it in that orbit. So we want the height from where this thing is orbiting. So 5.3, the first mark, or rather I will use Fg is equals to Gm1 m2 over r squared. We'll then substitute the force that the Earth exerts on the satellite. We'll then have 6.67 times 10 to the power negative 11 times 10 to the power times 10 to the power negative 11, yes, times 5.98 times 10 to the power 24, which is the mass of the Earth, times 419,725, which is the mass of the satellite, all over r squared. Then r will be, please correct it on your memo there, colleagues. Please note, I think there was an extra 8 there. It is 6781804,029 meters. That is the value of r. Then the distance from where it is orbiting, or the height from where it is orbiting, will be the r minus the radius of the Earth, as we usually do it, colleagues, when we have object orbiting above surface of the Earth. Then that will be the value that they will have got here, minus the radius of the Earth, which is 6.38 times 10 to the power 6. Then it gives us 401,804,0294. But remember the question, I think it was specific to say The answer must be given in kilometers because it says calculate how many kilometers. So the learner cannot end with the meters. They will then have to give an answer in kilometers. And then an answer with kilometers will then mean this answer here must be divided by 1,000. And then when you divide this answer by 1,000, we'll then get 401,80 kilometers above the Earth's surface. That will be the distance there. So that is the 5 marks for question 5.3. Then when it comes to question 5.4, it is observed that after some time, the net attractive force between the Earth and the satellite is decreasing. It is observed that after some time, the net attractive force between the Earth and the satellite is decreasing. Then if that is the case, then learners are asked, is the satellite moving towards or away from the Earth? If the force is decreasing, then it means what? It means whatever that is moving there, it is moving away because now the distance is increasing between them. If you have two objects and then the force between them is decreasing, it means the distance between them is increasing. And then the reason will be, according to this formula here, force is inversely proportional to the square of the distance. Remember, we need to refer to the, or rather use a physics principle or physics formula to give reasons. So according to this formula here, the force or gravitational force is inversely proportional to the square of the distance. Or Elena can give it in symbols. Here we were not specific. F is inversely proportional to the square of the distance. So that will be 1 mark. The mark allocation, we said 2 marks for 5.1. If a learner does not write the gravitational force, taking her weight and gravitational force is the same thing, and I can just start by saying the force exerted by Earth on an object for 2 marks. Let us give, but here it is 2 or 0. 0.2, 1 mark for the formula, Fg is equals to mg, or W is equals to mg, then 650 m multiplied by 9.8 for the whole substitution, 1 mark, and 1 mark for the mass. Then 5.3, 1 mark for the correct formula, 1 mark for substitution of the force, 1 mark for correct substitution on the right-hand side. That is 6,67 times 10 to the power negative 11 multiplied by 5,98 times 10 to the power 24 multiplied by 419,725 over r squared. The whole thing, 1 mark. Then the subtraction of this value, or rather of the radius of the F from this value that the learner will have got here, that subtraction, this thing, maybe let me underline it. This thing here, 1 mark, and then we do not give a mark here because the question asked for how many kilometers. Then the learner must convert these meters to kilometers by dividing by 1,000. So we don't have a mark here, but the mark will be on kilometers answer, which will be 401,80 kilometers above the Earth's surface. Even if the learner just write 401 kilometers, it is okay. We will give 1 mark there. Then 5.4.1 away, 1 mark. 5.4.2, force is inversely proportional to the square of the distance, 1 mark, or in symbols, F directly proportional to the reciprocal of r squared, which is inversely proportional to r squared. Then we give 1 mark there. So that is that for question number 5. I do not know if colleagues have questions. If there are, colleagues, you may ask.
Yes, and I'm happy. There's a question. The first one is from Mikitsi or Mr. Lamin, I don't know. Over to you, Mikitsi.
Yeah, it's Mr. Shani. Can you just go back to question 3.4 a little bit? If a
3.4.
learner, yes, sir.
Okay,
Sorry about that.
no problem.
If a learner says acceleration is directly proportional to the F net, will that be acceptable? No, in symbols. Still. A,
In symbols.
yes, in symbols.
Yeah,
A, directly proportional to F net.
yeah. Yeah, we will accept. You know, the reason I'm laughing, I get colleagues, the correct way of writing is on the conclusion. You start first by mentioning the independent variable, then the dependent variable. You know those small things, colleagues, we need to make our learners aware of them. Now, if a learner starts with, but it's a conclusion we can accept, but I'm just saying, or we need to make our learners aware of such things. I get it when we write the conclusion, the first thing that changes is the independent variable. Then after the independent variable, then comes the dependent variable. So the learner can't write it as if it is the dependent variable that changes first and the independent variable changes after. I hope you get what I'm saying in here. Let us accept for now, but please, colleagues, let us make our learners aware of such things. Let us make our learners aware of such things. And when they write these things in their, especially the experimental work, they need to be careful with the phrasing of the conclusion and the hypothesis. Change the independent variable first, and then the dependent variable will change thereafter. I don't know, maybe I'm being too strict, but such things, colleagues, can cost our learners marks in future. I see JT is also.
That's very important that I'm happy. Maybe I thought that Shahani will address what he has written on the chat as well, but I think you've already addressed that one. That I'm happy it was as per the 2024 exam guideline. It says the gravitational force exerted by the Earth on an object. Is that acceptable? I think you've already addressed that one.
Yes, yeah.
Yes. And then Mr. Taizan, I don't know, your hand is now lowered. I don't know whether you are covered or not. The hand is now
I'm
lowered,
covered,
that
ma'am,
I
thank you.
am happy, so we
Okay.
no longer have any hands. I think you can move now to the next question. Thank you.
Okay. Question number 6. This is now electrostatics, colleagues. The graph below represents the relationship between electrostatic force F between two identical charged particles and distance R between the particles. That is what we have there. Then the first question that the learners were asked to do was to calculate the gradient of the graph. You'll see, colleagues, even here, we said, no, let us give that extra 1 to calculation of a gradient here. At least, hopefully, our learners will get something. So the calculation of the gradient there, formula for gradient changes in y over changes in x, but then the learner must give us the variables that are used to do the calculation there. And then we'll have the points that the learner can use. It is that of 20 and 1. I think those are the most appropriate ones to use. So the difference, 20 minus 1 over 1 minus 20. I can't see any other point that the learner can use, but then if there is, or there are points that the learner can use that will give them the same answer, colleagues, maybe we will accept. But the most obvious one, it is that of 20 and 1 and 0 and 0. So for that, we'll then have 1 mark for substitution in the numerator and 1 mark for substitution in the denominator. That is 20 minus 0, 1 minus 0. And then the gradient of the graph will be 20 without the units, Newton meter squared. But if a learner gives the unit, then after working them out, we can accept, colleagues, is okay. So 1 mark for the formula, 1 mark for substitution in the numerator, 1 mark for substitution in the denominator, and 1 mark for the answer for gradient. And then 6.1.2. Then this question here, 6.1.1. Let us make it 4 marks. Then the 2 marks for 1.5 are exhausted now. Let us make 6.1.1 4 marks, colleagues. Then 6.1.2. Use the answer to question 6.1.1 to calculate the charge on each particle. To calculate the charge on each particle. Remember, they are identical charges. So if we use the gradient there, from the formula we can see that, or rather from the units, the gradient is force times r squared, which is equal to kq squared. So that is what the gradient is equal to. So the relation of gradient and the formula will give us 1 mark. Learners must be able to relate the gradient with the formula or an expression from the formula. The expression from the formula that the gradient will be equal to will be fr squared, which is equal to kq squared. I hope colleagues get what I am saying. We need to relate the gradient or the variables that we calculate from the graph with an expression from the formula. So our learners must be able to see, okay, from this graph, the gradient will be equal to this variable or this expression from this formula. So from Coulomb's law formula, the gradient there will be equal to kq squared. And then if they use that 20, and then they substitute k there, then they will find their charge or charge on each particle being 4.71 times 10 to the power negative 5 coulombs. And then we're saying it is positive marking from question, positive marking from question 6.1.1. Positive marking means if the answer here is wrong for whatever reason, but it is correctly used in 6.1.2, then the learner can get full marks. If the answer here is wrong for whatever reason, but it is correctly used in 6.1.2, then the learner can get 3 marks. And then we said, okay, even though the learners were then asked to use their answer from question 6.1.1, let us, for option number 2, accept if a learner uses Coulomb's law. And then if they use Coulomb's law, you'll see that now they are not using the answer that they got from question 6.1.1. They'll just substitute 20 and 1 as the values there. And then the charge will be 4.71 times 10 to the power negative 5. This is an accept option, colleagues. Maybe we need to specify, because actually the question wanted them to use the answer they got here. The skill that we wanted our learners to be to have is to be able to relate the gradient with an expression from the formula of physics. That was the intention of the question. But we said, okay, it's fine. Let us accept this one. Okay. Then question number 6 point, or rather on that, maybe let me explain it. If we accept this one, then 1 mark for Coulomb's law formula, 1 mark for substitution, correct substitution, the whole substitution, and then 1 mark for the final answer. That is how we'll mark it. But I must emphasize, colleagues, the intention was to get learners to be, or to check if learners are able to relate the gradient and the expression from the physics law or formula, which is the skill that our learners must learn and they must have, colleagues. Okay. Then number 6.2. 3-point charges QA, QB, and QC are placed as shown below. QA is R meters from QB, while QC is 2 centimeters from QB. The net electrostatic force on QA due to QB and QC is 0. Then the first question is state Coulomb's law in width. State Coulomb's law in width. I think here, colleagues, we can look at the context. It cannot be 2 or 0. If the context, one of the underlined weights will underline the weights in the final memo, which are important. And then if one of them is omitted in correct context, we can give learners 1 mark. But we'll show that in the final memo. But then the law, it says, the magnitude of the electrostatic force exerted by 1-point charge on another point charge is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Like I indicated, colleagues, here, we will have a note of saying if any of the underlined weights is omitted in correct context, then you can have 1 out of 2. We will include that in the final memo. So here it can be 2 or 0. Okay. Then the next question. Draw a free body diagram showing electrostatic forces. And here we are specific. We want electrostatic forces acting on charge A. Obviously, charge A will experience a force from QC. A will experience a force from QB. So the force that A will experience from C will be an attractive force. And the force that A will experience from B will be a repulsive force since they have the same sign. So the free body diagram that we are expecting there is like this. F of B on A towards the left, and then force of C on A must be towards the right. Let us ignore the length of the arrows, but if we were to consider them, obviously C is closer to A, then this will be, we will expect force of C on A to be greater and have a longer arrow compared to the force of B on A. That is the expectation, but we will not consider the length of the arrows, colleagues. So it is the force, electrostatic force of B on A towards the left, and the electrostatic force of C on A towards the right. This will be the correct free body diagram showing electrostatic forces on A. All right. Then learners were then asked to calculate R, which is the distance between charge A and charge B. Let us go through the memo on this one. So F net, remember learners were given that the F net on A is equal to 0. So we'll have F net being equal to, since they are moving in opposite directions, will be equal to force of C on A. You can say plus here, it's okay, force of K of BA. Then we substitute 0 for the net force. Then for the force of C on A, we'll substitute the values of A and C there, together with the distance between charge A and charge C squared. Then we say minus, remember they are moving in opposite directions, these forces, minus the force of B on A, we substitute the values for charges A and B, which is 400 and 200 microcoulombs. And the distance between B and A is what? Is R. So that will be the substitution. And if a learner has done this and done mathematics correctly, the answer there should be 0.04 meters. Please correct it in the memo there, colleagues, but it will be corrected in the final memo. I know the answer that we had there, it is something like 0.013, but then as we were preparing yesterday, we then realized, oh no, and the answer is 0.04 meters. So the answer there should be 0.04 meters. Then the mark allocation here, colleagues, will be 1 mark for Coulomb's formula, KQ1 Q2 over R squared. Either way, it can be on CA or on BA. That is 1 mark. The other mark will be on the substitution of 0 on the left-hand side for net force. When net force is substituted as 0, 1 mark. The third mark will be on the substitution into the formula for CA. For CA, that will be 9 times 10 to the power 9 multiplied by 100 times 10 to the power negative 6 multiplied by 200 times 10 to the power negative 6 over R minus 2 times 10 to the power negative 2 all squared. So the whole substitution as it is encircled there, it is 1 mark. That is the fourth mark. Is it the fourth? Oh no, the third. That is the third mark. And then the fourth mark, colleagues, will be a combination of substitution into the formula to calculate force BA with or and the minus sign that the learner will have seen from the free body diagram. Minus into that substitution into that formula 9 times 10 to the power 9, 400 times 10 to the power negative 6 times 200 negative 6 over R squared. So minus the whole thing, then 1 mark. And then the final answer, which is 0.04 meters. That is that when it comes to the marking of question number 6. Remember, colleagues, if there is any mistake in the substitution, then the final answer will be wrong. If there is any mark that the learner loses in the substitution, then the final answer will be wrong, because sometimes learners will do things correctly in the calculator, but then they forget a square, for instance, here. Then it means this substitution here will be wrong. And once the substitution is wrong, then the final answer will be wrong also. So please be careful. There are instances where learners will do everything correctly in the calculator or on the calculator, but what they have written is not what they have in their calculators. So the answer comes out correct, whereas the substitution here is wrong. So please be careful. If any mistake on the substitution, the answer is automatically wrong. Unfortunately, those are the principles of marking. So that is that, colleagues, when it comes to question number 6. Let me then hand over to Memanchu to check if there are any questions.
TV, we have questions on the chat. The first one is, please let us remember marking rule if zeros are omitted. That is in question 6.1.1.
Oh,
And then there's an,
okay.
do you want to address that one?
No. Thank you for reminding me. So a learner cannot just write 20 over 1. Then the learner must be 20 minus, or must write 20 minus 0 and 1 minus 0. Thank you very much for that reminder from that person. Thank you, ma'am.
And then the next one is 5.1.5.
5.
We don't have 5.1.5, so I don't know what. But it says saying no. We don't have 5.1.5, so I don't know which question is that.
Mebusi.
Okay, yes, Ndate Miketsi. You can clarify your question.
All right, okay. And I'm happy. What I was actually trying to say there is that the marking rule 5.1.5 says we can omit the zeros. So it reads thus: no penalization if zero substitution are omitted in calculations where correct formula or principle is given or correctly
Oh.
done. So we can, so it's only a special case for the coordinate of 0, 0. So we can be able to give. So I wanted to clarify that learners can say 20/1. Then we will still give them 2 marks for that.
Serious?
The marking rule says that in
Okay.
the grade 12. Yeah, I've just checked it now.
Okay, colleagues, can you please come in? Okay. Excuse me, maybe I'm taking over now.
For 611,
Mm,
I disagree with Ntate there. Remember, they're interpreting the graph.
mm,
So these coordinates are taken from the graph.
mm.
So there's no way we can omit the zeros.
Yeah. Yes, Ntate Teki, so please don't omit the zeros, Minir.
Okay, it's fine. So meaning we are ignoring that marking rule. I just want us to have that determination because it was specifically, I believe it was specifically written for substitution from, because there is nowhere else where you can have the difference at the top and below if it's not as from a graph point of view, and then why then is it a rule? But if we so want it, then it means we need to review that rule as well. Because I was just going according to the rules.
Okay.
Can I come in, Tate Mohapi?
Yes, ma'am.
And Tate Takisho, yes, it is the rule, it is correct. But if you remember, in grade 12, the only time where we ignore the zeros, that's when we are dealing with work, energy, and power. But in this point, in this situation, we need to see those zeros because those are the 2 points that the learner has chosen. Another learner can use any magnitude, but the answer must still be the same. So in this case, this question, the zeros must be shown, even on the one where F net is equals to 0. They have to show that so that they get that mark.
All right.
Okay, noted. And then lastly, then on that very one, then this learner still had their answer. There is a mistake or there is an omission in the substitution. Then what with the 20? What should I do with that 20? Mark it wrong? Because
Yes.
there's an issue on the substitution.
Wrong substitution, wrong answer.
Thank you.
Okay. I see Sharon.
Good morning, colleagues.
Morning, ma'am.
Naliputo on 6.1.1. If the learner they wrote for the formula gradient, by the M is equals to Y final minus Y initial divided by X final minus X initial. Do we penalize them for that formula?
Okay, and then they do not substitute force and 1 over
They-
R squared.
They substitute cardinal numbers fella to say
Okay.
20 minus 0 into 1 minus kappa any points by the kgethileng. For example, Kenali 0.4, it is 0.4 under the x-axis minus 0, and then the other one with the 8 minus 0. So for the formula, do I penalize Hasebidi say M is equals to?
Yeah, the maths one.
Yes.
Yeah. No, let us not give for the formula, but continue marking.
Okay, so they'll forfeit the mark for the formula, mathematics.
Yeah.
All right, thank you.
Correct. Thank you. Ntate Taetsane?
And Dr. Mapi, thank you for giving me opportunity.
Yes, Mini.
Now, if you move on to 623,
Okay.
and then a learner for the first step, F net is equals to KQ1, Q2 over R squared for CA as it is. And then Elena wrote that step. And then when he moved to the next step, they do not substitute that step. And the learner said, therefore, KQ1, KQ2 over R squared for CA is equals to KQ1, Q2 over R squared for BA, equating both of them there, substituted, and got to the same answer. How do we allocate the marks?
So a learner will have found this expression, this one. Separate. I want you to go with me in the data. They get to this expression, and then they equate it to this one. Okay, and then they get to the answer, because that is where it will lead eventually. But now that learner will not have shown
the substitution of zero,
and then this
and
negative also will not have
negative.
been shown. Ne?
Okay.
Yeah. Yeah. Ish. Because the formula is there, 1 mark, this substitution is there, 1 mark, this substitution is there, 1 mark. This relationship also, the only problem I have with this is that the relationship between the two and the zero is not shown. Yes. But if you look at it, somehow it is shown, though not in the way we want it in science. Because equating them means that their sum is equals to 0, but the other one is going in an opposite direction. That is not how we want them to do science and maths. Yes, that is not how we want them to do it, but I don't see anything wrong. Maybe colleagues will come and advise. If you understood what Ndato was saying.
Yeah, no, I do understand that. Thank you very much, colleagues. To make it easier, we still give the marks for both substitution. That will be 2 marks. And then for the sign showing that there is equal, those two are equal, let's give that mark on the equality part. Because that is what it is implying. For them to be 0, that means the 2 must be equal. So equating the 2 to, let's give that mark instead of the 0, just that mark of the 0, just put it in the middle, maybe as another option, so that at least we end up with the same thing. Thank you, Baba.
So we'll give 5, ne?
Yeah, we'll still give 5.
Yeah, I agree. Sharp. Yeah. No, Mr. Taizan will give me, but we need to teach them to do it like this for easier marking. Sharp.
That I'm happy still on 6 to 3. For the formula, remember F net is the sum of forces. So that negative, I advise you write positive.
Okay.
Yes, and then the negative will be on the next step. Thank you.
Okay. No, thank you very much. Let me do it clear, man, so that I don't forget. Eben. No, thank you very much. I see, Mwikets, you have your hand up again.
Dumelang Ntate Mohapi, Mr. Mike.
Mr. Mike.
I just wanted to clarify.
Are you asking a question?
No, I just wanted to add to question 6.1.1 with the one where we have to calculate gradient. Number 1, when we calculate gradient in physical science, we don't use the symbol letter M to represent gradient because that has a different meaning, which is mass of an object. So we need to clarify this with the colleagues to say the small letter M, or that formula M is equal to delta Y over delta X, must be left in mathematics. The Y and the X have a meaning here in physical sciences. So M cannot be used to signify gradient. It must be written in weights, or unless if the learner knows what the gradient actually represents, then they may use a symbol. Number 2, that delta Y over delta X, I'm glad that you said we are not going to accept it because the Y and the X have a meaning and they are there and given on the graph. So it cannot be that we are still discussing the fact that we should accept M is equal to delta Y over delta X. even that extended version of the formula of y final minus y initial over x final minus x initial cannot be accepted because the x and the y, they actually have a meaning represented by f and 1 over r squared. That is what I wanted to add in here.
Yeah, but you do agree that we can at least, a learner can forfeit 1 mark for the formula, but we can continue marking, eh?
Yes, Menier, yes.
Okay, sure.
Dr. Mohapi, can I come in there?
Okay, ma'am.
Why do we disadvantage learners while we know very well that they're doing the graphs in the mathematics and the gradient is still gradient? The only thing that we must be careful of is when at the end, the learner, if the SI unit was not in brackets, that's when the learner is supposed to give the correct SI unit. But in this case, I feel that we are too harsh if we penalize learners for the formula that they already know from mathematics. And learners cannot do physics without doing mathematics. That's my opinion.
Yeah, but the opinion will be the gradient changing y over changing x is from the graph of y against x, isn't it? So
Yes.
here the graph given to them is a graph of f over 1 over r. It's not a graph of y over x, isn't it?
You know, the sad part is that in grade 12, we don't award a mark for the formula for gradient to avoid this.
Such things, yeah.
Yes, that is why the mark is not awarded. Hence, I'm saying because now the marks have changed, then you are penalizing the learners with the correct skill that they have shown that they understand the graph, even though they used X and Y's. And they are still X and Y's. We just put the different SI, the physical quantities there.
Yeah, but remember, I'm of a different opinion. I'm of a different opinion. I think we shouldn't give for X and Y because here we are using 1 over R squared and F. So we don't have a standard formula for gradient, especially in physical sciences. So the learner has to check what is it that is used to draw a graph and then take that to calculate the gradient. Is a difference of opinions on that one. Yeah, no, let us conclude with not giving, man. Will not give for now.
It's fine. And then
Thank
on
you.
623, remember now the learner can choose the other side as negative.
Okay,
So please include the other option whereby f of CA is negative and then f of BA is positive.
Okay. Okay, thank you. I don't know, Memanju, is there anything in the chat?
Now that it's addressed.
It's addressed. Okay, and then colleagues, can we move on to the next question, which is the last one, question number 7. During a science fair, 2 learners built a simple model to demonstrate how charged objects interact. They placed 2 small metal spheres, P and R, as shown below. The distance between the 2 spheres is 0.4 meters. Point X is located exactly midway between them. Then 7.1 learners are asked to define the term electric field. Then the definition of electric field will be a region in space in which an electric charge experiences a force. Electric charge experiences a force. So electric must be there, colleagues. If learners can't just write where a charge experiences a force, it must be an electric charge experiences a force. That is what we had last year in December. So it is 2 or 0. And please be careful that the learners do not define electric field at a point. They must define electric field alone, not electric field at a point. So they must start with a region of space. Then the next question, draw the resultant electric field pattern due to metal spheres P and R. Then they are oppositely charged. We'll have a diagram like this showing two spheres with different or opposite charges. Obviously, they will have an attraction. So the marking criteria for the electric field pattern will be correct shape, correct direction of the field lines, and then the shape of the field lines outside the charges. Correct shape. It is the pattern that we have here. That is what we will be expecting. The direction of the field lines for both Q1 and Q2, we know for Q1, they will be moving into. And then for Q2, they will be moving away from the charge. And then correct shape of the field lines outside the charge. These are the outlines. It is this part. We know all these field lines must bend outward like that. They must, for Q2, which is a positive charge, they must bend outward like that, except for this one that is directly opposite Q2. It is the only one that can be straight line. But all these other ones, they must bend outward. Then for Q1, because they are moving into the charge, so not these outward ones, they must bend into a charge like that. And then there's one that is directly opposite the charge. It is the only one that can be straight. But all these other ones, they must bend. So outward, that is what we mean, colleagues. The outward field for a negative charge, they must bend inward, except for this one that is directly opposite the charge. They must bend inward. For a positive charge, they must bend outward, except for this one that is directly opposite the charge. And then in the middle here, the one in the straight line, yes, it will be straight line, but these other ones for positive, they must bend outward. Here, they must bend inward like that, outward, inward like that. So that is that. I think for this marking here, we'll also need a note. For instance, if there is one field line that does not touch the charge, then what do we do? How do we deal with such instances? If there are field lines that are moving into the sphere, how do we deal with that? We'll make a note on that also. But in terms of the marking of the field line, correct shape, direction of the field lines, each field line must have direction, shape of the field lines outside the charges. I think I've explained that. Then that will be how we are supposed to mark question 7.2. And then we move on to 7.3. Calculate the strength of electric field at point X due to metal sphere P. Due to metal sphere P, we are asked to calculate the strength of the electric field at X. So they are all that point P is in the middle of the two charges. Therefore, it will be 0.2, the distance between P and the charge. So the formula there, P is the charge, or X is the point, yes. So P, or rather X, is directly in the middle of charges P and R. So electric field due to P at X will be KQ over R squared. Then that is 9 times 10 to power 9 multiplied by 3 times 10 to power negative 9, directly in the middle, midway. Then it will be 0.4 divided by 2, or if a learner just writes 0.2 there squared, we will give the mark. And then if we were to draw the vector diagram there, we'll see that electric field at point X due to charge P will be 675 Newton per Coulomb to the right. So the mark allocation, 1 mark for the formula, 1 mark for the substitution in the numerator, 1 mark for the substitution in the denominator, and then 1 mark for the final answer with the direction. Because we did not ask for the magnitude of the charge, but we asked for electric field at point X due to P. So it is 675 Newton per Coulomb to the right. Okay. Then the last question of the question paper. Two learners claim that the electric field or the net electric field at point X due to metal spheres P and R is 0 because it is exactly midway between them. Do you agree or disagree with the learner's statement? Then learners were expected to justify whether they agree or disagree with a calculation. So they will then have to calculate the net electric field handling, and then check if that electric field that the net electric field that they calculate is equal to 0 or not. So how will they go about doing this? Positive marking from 7.3 into 7.4. We don't mark for the formula. We'll then have to calculate electric field at point X due to charge R. Due to charge R, it will be the substitution there. Direction will be to the right also. Learners will then realize, okay, because when you place a positive test charge there, it will be attracted by R because R is negative. So electric field at point X due to P and due to R, they are both to the right. Hence, the net electric field at point X due to R and P will be 6.67 from 7.3 plus 6.67 that we will have calculated here. And it will give them 1,350 newtons per coulomb, which is greater than 0. And they must conclude or write this and say E net is greater than 0. And the learners wanna concluded or E net is to 0. So E net is greater than 0. Therefore, we disagree with the statement. So the mark allocation will be the calculation or substitution into calculation of electric field at X due to R. Substitution into the formula to calculate electric field at X due to R. And if learners apply their size correctly there, they will realize or this electric field at X due to R is also going to the right. And then when they get the net electric field due to R and P, they will then see that the net electric field at X due to R and P will be 13 or rather 1,350 Newton per coulomb, which is greater than 0 that they said is equal to that. Then the answer will be disagree. 1 mark here, 1 mark for the sum, and 1 mark for adding the answer they got from here. 1 mark for saying or realizing or the E net is greater than 0, and 1 mark for saying they disagree. That is option 1. Option 2, if they have realized or but the magnitude of the charge of R is the same as that of P, and the distance to point X is the same. Therefore, the two must have equal magnitude. The electric field at that point, they must have equal magnitude. We can give 1 mark. And then the addition of that to get to 1,350, we'll give 2 marks like we did in option number 1. We still need them to say E net is equals to, or because that is what they've realized, E net is greater than 0. And then they say they disagree. That is how we'll allocate the last 5 marks, which is for question 7.4. Colleagues, that is where we will end with the marking guideline discussion for grade 11 paper. But before we close, I just want to check if there are any questions on question 7. And then after questions on question 7, we'll then look at the questions anywhere in the paper, then we'll close. So let me open this for any clarity seeking questions for question 7. It's,
And I'm happy there's a hand from Mr. Taizani.
okay. Mr. Taizan.
That might be question 7.4.
Okay.
Yeah. That mark F E net is greater than 0.
Mhm.
A learner said E net is not equals to 0.
Mm.
Everything it is as it appears in the memo, but there it just said E net is not equal to 0.
Yes, we will give, Minia.
Thank you, Minister.
Thank you very much. Yeah, we'll give for that. Thank you.
And then on chat, there's a question on 7.1. It says 7.1 is really creating confusion. Last year, memo discussion, a region was declared a description, but in 2026, we reject was experienced. I get to wake up away. We can't let them have.
A region was.
Or maybe, Jalifa Mukwena, can you unmute and explain what you say?
Yeah, I do not know, because I remember, can we colleagues speak to definitions as they come from examination guideline? I don't know what Minir is referring to, but this definition for electric field, it comes directly from the examination guideline. So when it comes to definitions, can we stick to definitions?
Yeah, good morning again, colleagues. With that question 7.1, I'm happy. The only problem with that question, it is if maybe our learners are using the definitions and being who they are, immediately, if we look at the examination guideline, for electric field, it says we need to describe the electric field, but we have to define electric field at a point. So that part, it is the one where it is creating a confusion. When are we asking for a definition and when are we asking for a description or an explanation? So in this case, because we're looking at electric field, it should have been
described.
And then if it was for a definition at a point, then it should have been a definition. But for this case, yeah, because we are saying it is electric field, and then in a way we're having some sort of a lead in putting the emphasis using italics. So let's take that the first part of that question, it was the one that was creating some bit of a confusion here and there. But in essence, it shouldn't have been.
Okay.
So yeah, it is not that we are creating a confusion in saying whatever we are saying, but it is the way the question it was phrased that it is creating a confusion.
No, I get what you're saying.
Yeah. Okay. Thank you, Nat.
So what will be your advice, Minir? Because of the phrasing of the question, can we accept the other definition?
Yeah, I was saying that. Yeah, I was gonna say maybe because of that, being our learners, immediately that they see the describe, then they will maybe let's give them a benefit that we accept for the description of electric field, and then we accept for the definition of the electric field at a point. Because basically it is just almost the same concept, it's just that it is specific into which area are we talking to.
All right. No, I think it is clear. We will also include that in the final memo. Yeah, colleagues, let us accept, given the reason that NTA is making us aware of. So yeah, we'll accept.
Yeah. The other thing, Dr. MOHAPI, even though here we are going to accept, and maybe can colleagues also, they are having their question papers with them. And this is what also came up last year. If they go to the instruction and information, which is given every time, and they look at instruction number 9, specifically number 9. If we can just show us maybe there, number 9. It says there we have to store all formulas and show all substitutions. So in some instances, there were parts where we are saying, where we are having 0.4 maybe divide by 2, and then the learner just put in 0.2 accept. Really, it shouldn't be, because it's an instruction and then it is always coming like that. So even where we are having the acceleration, that -2 in the acceleration, it should have been that we have to show all those calculations and all the substitutions. So for now, let's accept it's a learning curve for everybody, that every time we need to show whatever we have to show as a substitution, and not just put in any value and then you say that value, because it is an instruction that it is coming. And this instruction are the same for provincial and for national papers. Thank you, Bob.
Yeah. Okay. No, thank you very much. Okay, thank you very much. I know I agree with you. And then shouldn't we punish so that we learn now for future rather than acceptable? Yeah, I thought I'm strict, but I think we should punish colleagues, because now these learners must learn. At least it is still early now. And we should go with the correct information, and our learners must be guided correctly. So if a learner comes here with -2, like Ndadenzi is explaining, I think we should punish them. I don't know, what's your feeling? We need learners to show all the calculations.
That is an instruction, and that the learners need to follow. It is the same as the instruction that they have to show the final answer to a minimum of 2 decimal places. So we cannot be selective which rule are we saying, or which instruction are we carrying, and which one we are not going to carry. We have to be consistent all the time with whatever we are doing.
No, thank you. Thank you very much. I think now, colleagues, we are changing. I think we need to go with what Ndadenzi is advising here. Let us not accept if a learner does not show the calculation. Let us not accept with a substitution where we do not know where the 2, for instance, comes from. The learner has to show all the calculations. And remember, if the substitution is wrong, the answer will be wrong. Thank you very much. Memanchu?
There's the hand is now lowered in that.
Okay.
Mr. Nambani is agreeing with you and Ndadenzi.
You want something?
Okay.
Yes, Mini.
I just wanted to talk, and this has nothing to do with a general question from this question paper, but or a specific question rather, but it's general feelings that I have with regard to graphs. Taba ya delta, how calculate gradient, starting with the gradient of saying delta y over delta x. That formula, it is not a standard formula, it's subjective, because we can change even in mathematics and say y can be represented by k or x can be represented by l for that matter, which means that the formula will change to being delta k over delta l. So that delta y over delta x is not necessarily really standard formula that we use. It's important that in physical sciences, we run or move away from teaching calculating of gradient as delta y over delta x, because it's a misconception. Same thing as with when we have a straight line graph and people just assume it shows a direct proportion without considering the fact where it starts. So such teachings, they create unnecessary misconceptions. And also it is important that we use variables that are given in the graph in physical sciences, so that learners can be able to then identify what does the gradient represent? Because if you're saying to a learner, here is a graph of f versus 1 over r squared, and you are saying use delta y over delta x, how will you then explain to the learner what does the gradient of the graph represent? So we are really misleading learners when we are supposed to be using f over 1 over r squared. And this is not only limited to Newton's law of universal gravitation or Coulomb's law for that matter. For every equation and every possible graph that shows this direct proportionality or any form of a straight line graph in physical sciences, we must contextualize the formula and use the given symbols. And I feel like it's creating misconceptions, but again, it's my opinion. But that is what I just wanted to say with regard to graphs. Thank you.
No, thank you. Thank you very much, Minier. I totally agree with you. I think you have put it very nicely for us. No, thank you very much. But I think that point we had concluded it. Yeah. Can we now check on the questions on this memo, colleagues? Is there anything before we close the meeting that you would like to ask? On any question? Oh,
Don't move from that one, yeah, 4.3.2. Now that the final verdict is if the learner says -2 for acceleration, we penalize. Please explain everything. What happens to the 5 marks? Here's a learner that says -2. Then how do we allocate all the marks since it affects even the final answer? Please explain, be clear on that one. What happens to the 5 marks?
yeah, because now, according to that, then the learner will only get a mark for the formula. Or rather,
is coming in.
It's coming in.
Okay. No, it's fine. Yeah. Colleagues, let's get it. That there is a mark for the formula. Now, the mark, you can see there is a mark for the whole of that substitution. Can you see that mark? Do you see that mark that I'm having?
I see.
And then according to you, there is a mark inside where we are having 2,000, of which it is the same mark, meaning that we are giving 2 marks for that. The same substitution is for the. You say there is a 2,000, 1,200 multiplied by 6 minus 10 divided by 2. There is a mark for that. That mark is for the whole, or is it for part of that? And then there is a bracket and the whole mark again. What is that other mark inside?
This mark here, the one that I've highlighted,
yes.
It is the mark for calculation of acceleration only.
Right. Now, if that be the case, that means if that learner is not showing that calculation, is not showing that calculation. Now we have to penalize for not showing that calculation. But the whole of that substitution then becomes right. We cannot penalize 2 marks for the same mistake. So that would be saying, then we'll continue marking, and then that learner will get 4 out of 5.
Okay. All right.
Can I say something just in agreement with Ntate Ntsiye? I agree very much so that the second mark being for calculation, yes, it shouldn't be given. And then now, probably for me, I would say it will be 3 out of 5 because of the mistake in the substitution. So meaning there's a mistake in the substitution because of not showing all the work according to Rule 9. And then that being the effect, then they don't get 2,400 newtons. The same way as we dealt with the substitution into the gradient.
Yeah.
Thank you.
Let's take it this way. If this learner is saying, I'm looking at the calculation for the acceleration, now he's committing a mistake in the calculation for the acceleration, then we'll be saying he's taking the very same wrong calculation and he's substituting correctly into the principle. We are giving a mark for that, isn't it?
Yeah, that.
Yes. So that means this learner will then get a wrong answer, which is not going to be negative 2000, 2004, right? But in this case, this learner, he is giving us the correct substitution of the acceleration, although he didn't show the calculations correct.
Okay.
So those should be the two scenarios that I'm giving, that in one, we are going to give a 3, but in the other one, we need to give a 4.
Okay. All right. Noted in that.
Thank you.
Okay, colleagues, I think that
think it
makes
is
sense.
clear.
Let him have. Yes,
No, I think
it
I
is
think it is
clear.
clear, ma'am. Yeah.
Mm.
I think it
I
is
think it
clear.
is
It's
clear.
fine. Okay.
Yes.
I don't know
In
if there
this
is any
case,
other
the
thing.
learner that says. Nothing on the chat and no other hands. So I think because of that, I just want to thank everybody for participating in the meeting. And I'm happy with your team. Thank you very much for the good job well done. Whilst I'm concluding, there's a hand from Moteo, Science 14. So I think I can go back to Moteo, Science 14 then. Moteo, please unmute.
All right, Dumela ma'am Manso. Hello, ma'am.
Hello, ma'am.
Yes, we can hear you. We can hear
Yeah.
you. Continue.
The very last question, 7.4.
Can you come closer to the computer, please? You are far.
The very last question, 7.4. Do you agree or disagree with the learner's statement? And if the learners start by answering that question and says disagree, and then do a calculation, a very wrong calculation, of course, or even not even doing a calculation, do we credit that learner with a mark for disagree? Or don't we credit the learner with a mark?
Yeah, it is an independent mark will give me. Yeah.
Okay, thank you, sir.
Okay, thank you so much. There's another question. Migezehani.
Thank you very much. Kinda de Dlamini.
Yeah, that's a minute.
Yeah, can you go back to 3.4?
3.4.
Yeah. Yes. Yes.
Yes, you can, media.
Yes, sir. Mr. Shani raised Tabayao Rintate. If the learner said that acceleration is directly proportional to FNet, then we must give the learner a full mark, right? And then I just couldn't understand your reasoning correctly because of my view is that if in the formula, the formula says that the FNet is directly proportional to acceleration on the basis that if there is going to be a net force acting on an object, then the acceleration will change. There will not be any other instance whereby acceleration will change unless something happens to the net force. So if then we allow her acceleration is directly proportional to the net force. It's like now the learner is saying that there are instances whereby the acceleration itself can change the normal force. Is that correct?
Yeah. But if you are listening, I tried to explain it. Or usually we will want learners, whenever they give the conclusion and hypothesis, to start first with the changes in the independent variable. Then the change will be on the dependent variable after. That is what I was saying. And then the conclusion was, no, let us accept in this case, but encourage learners for future that the phrasing of their conclusion and hypothesis should be in that way where you change first the independent variable and then after the dependent variable will change. Now we are in agreement, meaning we agree, né? But because here we are just looking for the relationship between two variables, we then said, let's agree to accept. But when we go back teaching our learners, we are saying independent first, then the dependent after. Now we agree. But here we are just looking for the relationship between acceleration and net force. Hence we said, okay, let us accept. Yes, Minia.
Thank you, sir. That I'm happy. Can we go to question 5.2?
No, that Minia has okay.
I think we did that.
Oh, okay, no, thank you.
Yes, thank you very much.
So we are moving to what now?
Question 5.2, Menier, just an alternative method to the one that we have.
Okay.
An addition. So there's a learner who used Newton's law of universal gravitation, F, which is equal to G(m1, m2) over r squared. And under F, she interpreted that F as weight, so it is W. And then she calculated one of the masses and got the same answer.
Okay, yeah. No, it's fine. Yeah. No, it's okay, Minia.
It's
an option.
Yes, Minia.
Okay, Sharp Minia, we'll look into it. Yes, thank you. Mr. Gamin.
So that does it mean the question on that situation? Does it mean formula F, the one we used in 5.3, would be relevant in 5.2? So the learner, if one has a formula in any form of attempt to substitute, should we give them a mark? Because the other learners. Okay.
Because I get it, the formula that we mark must be the formula that leads to the answer. Okay? So we'll then have to see the relation between that formula and the other formula that leads to the answer. Hence, I'm saying we'll look into it, then we'll work it out in the final memo. You'll get the final with that option, and then the mark allocation will be indicated there. But the formula that we mark usually is the formula that leads to the answer. Okay.
Thank you, sir.
Sharp. Mancho, I do not see any other hands, but I must say I'm very happy with how this session went because it now turned into a sort of a content workshop on marking, which is very good. I'm really glad that we had this session the way we had it. I don't know from my side, that is where we'll end, and then we'll then issue out the updated memo later today. If colleagues have other options, please share them with your subject advisors so that they can forward them to us, and then we'll then finalize the memo. Before the end of the day today, we'll then release the final memo. Thank you very much, ma'am.
Thank you so much, and I'm happy for the discussions and the explanations, and thank you to your team as well for the good paper that has made it possible for everyone to, share their views, and that will also remove all the misconceptions. And colleagues, thank you very much for your contributions. Please make sure that in all the other memo discussions, you contribute this well. Remember, this is a standardization of our marking guideline, so your contributions are very important. Thank you very much, colleagues, and the meeting is adjourned.